Welcome to this webinar, Reducing Costs and Achieving Value with VRF Systems. This event is brought to you by Engineering News Record and sponsored by Mitsubishi Electric. Hi, I'm Scott Seltz, publisher of ENR, and your moderator for today's webinar, and thank you for joining us. Variable refrigerant flow systems solve many challenges associated with commercial construction and facility management, and less known are the opportunities to avoid or reduce costs with VRF systems. This webinar will help dispel misconceptions of VRF technology as expensive and explains how building owners can realize financial savings and competitive advantages throughout the system's life cycle. Joining us today from Mitsubishi Electric Trane HVAC US are Kevin Miskowitz, Senior Director of Vertical Markets, and Jose Hernandez, Commercial Regional Sales Manager. With the company since 2014, Kevin Miskowitz is a Senior Director of Vertical Markets, leading targeted business development initiatives along with commercial contractor development and commercial business strategy. Since joining the company also in 2014, Jose Hernandez has partnered with architects, engineers, and design build communities on commercial applications, educating project teams on the benefits of VRF technology. He's based in Dallas-Fort Worth area. Now, before we begin today's presentation, please enjoy this brief instructional video on how to use your webinar console.
Welcome to this webinar. Before we begin the presentation, I want to provide you with a few housekeeping items. On your screen, you will see a taskbar with icons. Each icon is assigned to a particular element of today's webinar. Click on the person icon to learn more about today's speakers. Throughout the presentation, you can network with others or submit questions to the speakers in the Q&A and chat box next to the slides. Download resources from the cloud icon. After the webinar is over, please take our survey to tell us how we did. Today's event is being recorded and archived and will be available within 24 hours. For on-demand questions or comments, send us an email by clicking Need Help? Email us. If you experience any technical issues today, please refresh your browser by hitting F5 for PC or Command R for Mac. And now I'm excited to turn it over to today's moderator.
Don't forget to submit your questions, and later in the program, our presenters will address as many as possible. Today's event is being recorded and archived on enr.com/webinar, so you can share this presentation with your colleagues. And now I'll turn it over to today's first presenter, Kevin Miskowitz. Kevin?
Thank you, Scott. Good afternoon to those joining us on the phone, and welcome to today's webinar. Jose Hernandez and I are excited to spend the next hour discussing the HVAC industry, and more specifically, an introduction to variable refrigerant flow, or VRF technology, and its cost reduction benefits, along with sharing a few real-world examples of successful applications. Today's webinar will cover the following topics. Explain how modern construction, decarbonization, and rising energy costs drive the popularity of VRF technology. Describe how the characteristics of HVAC systems affect building requirements and total first cost. Explain how the characteristics of VRF systems enable owners to reduce and avoid costs. And explain how VRF systems create competitive advantages for building owners. We'll leave plenty of time for questions at the end of today's presentation, as Scott mentioned, and look forward to answering them for you today. Be sure to submit them throughout the presentation by using the Q&A function through the presentation software. It's no secret that buildings and the ways in which we utilize them are changing at a rapid pace. The impact of the global pandemic has accelerated the discussion around the future of the office and how we ensure the spaces we occupy each day positively contribute to our health and our well-being. Another topic of conversation is how to control rapidly rising energy costs along with our country's dependence on fossil fuels. The incoming federal administration in the U.S. will almost certainly place an emphasis on shifting our country's energy infrastructure in a more sustainable direction. However, that won't be accomplished without significant investments from the public sector over the next decade or more. Within the private sector, building owners and developers have sped up their conversations around how to combat the rising costs of electricity while managing to modern construction and building occupant requirements. Decarbonization and strategic electrification efforts are on the rise in cities large and small, along with identifying sustainable ways to design, construct, and manage both existing and new buildings. These two concepts, the concept of reduced energy usage and the concept of modern construction practices, can seem to be competing with each other at times. Throw in a few more demands, such as policy mandates, tenant fit-out, tenant comfort requirements, and it can seem like an insurmountable challenge for a building owner or developer to construct and manage the ideal building. Policy mandates have become a driver for building updates and new construction requirements. In California, for example, the state's energy efficiency strategic plan requires all new commercial construction to be zero net energy by 2030, just 9 short years away. In New York City, Local Law 97 sets carbon dioxide emission intensity limits for large properties, and in my personal opinion, is moving in the direction of an outright ban on natural gas consumption within the city. Building owners can face financial implications if the carbon dioxide emissions from their building exceed the established benchmarks. Utility companies are increasingly offering incentives to building owners who adopt energy-efficient mechanical systems and building materials, a practice that has long been in place within single-family home applications. An astute owner or developer can work with their project team to reap significant savings if they carefully consider the materials used in their new construction or retrofit project. Lastly, tenant experience and tenant comfort remain a significant priority for owners. You can utilize the most efficient materials, the most efficient construction methods that are available to you on the market. You can meet all the green certifications in the world, but if your building isn't comfortable or you don't pass some savings to occupants, tenants simply won't rent the space. So that leads us to the challenge that many developers and owners and their project teams are facing. It's all about the and when it comes to energy efficiency and occupant comfort. Buildings need to be built or upgraded to become more energy efficient without sacrificing comfort and utility savings, which really do matter to tenants. These upgrades can be proactive, such as trying to achieve a utility rebate, or they can be reactive, such as adhering to a policy mandate to avoid a steep fine. Upgrading a building to achieve goals can come with a hefty price tag. Before investments are made, an owner or developer wants to ensure that those investments will bring a return and allow them to achieve their tenants' goals and comfort requirements. This is especially prevalent with HVAC upgrades, which brings us to the topic of conversation today, variable refrigerant flow technology. This electric-based system allows you to achieve the goals previously described while providing a superior comfort experience for your tenants and increased flexibility for your building. While VRF systems can be perceived as expensive at the outset, the concepts we'll walk through today will demonstrate their energy and cost savings and occupant comfort benefits and really showcase that in the end, they're not as expensive as one might think. Before we jump into the discussion about VRF systems, let's pause for a brief polling question. Your answers will help Jose and I gauge your current mindset around VRF systems and their real and perceived costs. I'll read the question twice to give you some time to answer and choose from the radio buttons on the screen. Does the first cost of VRF hinder your customers from considering these systems for your projects? Yes, no, or simply not applicable? Again, does the first cost of VRF systems hinder you or your customers from considering these systems for a project? Yes, no, or not applicable to you? We'll give it just about 10 seconds here for everyone to get their responses in. I know we have quite a few people on the phone to go through and give their responses, but we do appreciate your feedback. We do appreciate you answering the question at the onset here. It'll really help us guide our remarks in the right direction to make sure we're hitting on what's important to you and your mindset as well. All right, with that, we'll go ahead and close the poll and move on to the results. looks like a majority of you say yes, that VRF systems really do hinder your customers from putting the systems into their projects. So that's helpful for us to know. I know Jose is going to touch on several different cost concepts in his remarks. And without further ado, I'm going to go ahead and pass the presentation over to Jose, our commercial regional manager at METUS based in the Texas area, for some deeper insight into not only the world of VRF systems, but how they can help you achieve your energy efficiency and cost savings goals. Jose?
Thank you, Kevin. Appreciate that. Again, today we're going to show you that VRF technology can be a true solution for the modern challenges owners and developers face, whether it's a retrofit or a new construction. Additionally, we're going to show you how to explain to a developer or building owner that they can install a premium VRF system for the same total cost, if not lower, than the cost of a less efficient conventional system. Now, the HVAC landscape is changing, as Kevin pointed out, and there's a big push to applying VRF in retrofit and new construction. For commercial spaces where comfort is the primary driver, such as hotels, office spaces, VRF is becoming more and more the preferred system over PTACs and conventional systems. And this is because VRF is all electric, it's versatile, and its application and design, as well as being cost effective. Now, before we jump into the benefits, let's review how this technology works. Here you can see a diagram of the outdoor unit connected to the indoor units via the red piping. The indoor units are in the zones and can be ducted or ductless. The entire VRF system is connected and controlled via standard controls that come with the system to communicate with all the components, whether it needs to deliver heating or cooling. In contrast to the VRF system, conventional systems like the one shown here, a rooftop unit with a single zone is connected to the space with ductwork. This ductwork, again, is connected to that rooftop unit to deliver the heating and cooling necessary for that building. Now, with this application, there's typically large ductwork, and you're going to have to balance the system to make sure that the comfort level is where you want it to be. Again, we've been doing that quite a while here in the States, and it requires a lot of energy to move that air, as well as the different components that require to control the system to deliver the comfort that you need. A good example of some of the comfort problems that this creates is in a commercial office where you have 3 or 4 offices sharing one unit that is controlled by one thermostat. If we look a little deeper into the differences, for most cooling systems, the heart of the system is the compressor. Here you see the compressor on the graph for a VRF system in red and a conventional system in gray. The conventional system first will modulate by turning on and off to satisfy the space temperature. When the system is off, there's nothing happening. There's no cooling, there's no air filtration, there's no air movement, and this leads to the temperature swings off of the set point that you see shown. Now let's look at the VRF compressor, which can go from off at the beginning here to set point really quickly by ramping up. In this case, it varies its hertz to get to set point quickly and will modulate on and off throughout the day. It will not turn off. It will just hover around that set point to deliver the cooling and temperature adjustments that you need throughout the day as people come and go out of a conference room or as tenants come and go out of their office spaces. Now, this allows it for quick response to that temperature change. This also gives you some added benefits of continuously filtering the air in the space and keeping the air from becoming stagnant. Very important during this current climate. Now, let's dig a little bit deeper at the differences between VRF and the 2 types of systems that you will find within VRF. VRF systems can be heat pump or heat pump with heat recovery. Shown here is the heat pump option that allows for heating or cooling. Typically, this is going to happen in spaces where the load profile is uniform. think common areas, some entryways, maybe an auditorium. And again, there's a lot of flexibility still within this system, in that a system that is calling for cooling can have a set point of 70 degrees or can have a set point of 76 degrees, still in cooling, but still delivering the comfort that person needs. Next, we look at a heat pump with heat recovery. This system consists of an outdoor unit, an indoor unit, and a branch circuit controller. This allows for simultaneous heating and cooling, where one unit will be in heat and the other one will be in cooling, as depicted here. Now, the biggest difference that you'll see between the heat pump and the heat recovery option is the branch circuit controller. The branch circuit controller allows for the system to deliver the refrigerant in the right mode to the indoor unit that's calling for heat or the indoor unit that's calling for cooling. Essentially, it directs the refrigerant for the communication with the outdoor unit and the indoor units to provide the application for that zone that you need. And it's ideal for offices, hotels, multifamily, anywhere where the facility needs are diverse. Another helpful feature of VRF systems is the variety of indoor unit equipment. This flexibility allows designers to select the right indoor unit based off the application or aesthetic. Again, you can have ductless or ducted units here. Shown is the multiple position air handling unit. Additionally, we have some ductless units like the 4-way cassette, which can be 2x2 or 3x3. Ductless units are more than just wall mounted, and you can get them in ceiling suspended or floor standing. Another huge benefit of VRF systems is that you can mix and match these components. The indoor units can be a mix of ductless and a mix of ducted units to give you the aesthetics that you're looking for in that space. So now that we've had a good explanation of what VRF systems and how they operate, we can dig a little deeper into how these systems provide significant savings for developers and owners. When viewed holistically, VRF systems can reduce your first cost by reducing architectural costs, which we'll get into a little bit deeper later, as well as electrical requirements and structural needs. In my 6 years at Mitsubishi, we've encountered many instances where owners and developers have been told that VRF is too expensive and not in the budget. I think one of the reasons is that we're not looking beyond the mechanical bid and how we can really justify the VRF as a holistic approach to building design. In the following slides, we're going to describe for you the areas of the project where VRF can level the playing field. In most instances, we're going to help get the project off the ground because it's going to be a lot cheaper to install than, say, a chilled water system. First, let's look at maximizing the space. VRF accomplishes this by a few ways. One, in reducing the size of the plenum required. Less bulky ductwork can lead to a plenum reduction of 6 to 8 inches depending on your application and the floor type that you're targeting. Also, depending on the application, you can completely eliminate the mechanical room. An example of this is a speculative office that I worked on here in Dallas, Texas, that the developer was going from a 3-story to a 5-story application. In the 3-story, they used a rooftop VAV application, but they realized that to get to a 5-story building, they needed a different approach. And in comes VRF, and initially they were told it was too expensive, but we looked at ways that we could save on the floor-to-floor for their tilt wall that led to savings of over $100,000 just by reducing that plenum height by 6 inches per floor. An example where we remove the mechanical room, the VRF can give you back valuable space that can be used to generate income. Here you see the two side by side, where the conventional system on the left and the VRF on the right. As you can compare, the extra space from that mechanical room can now be used for an additional office or can be used as leasable space. This allows for amenities the tenants will enjoy. Typically, you're going to add a rooftop bar, maybe some green space, which is going to be highly desirable for the way that we move forward in office application. Stratton Square, one of the applications I worked on here in Waco, Texas, after removing the chiller from the basement, the developer was able to go in and add a speakeasy to that basement floor, and again, open up the space for rentable, usable space that he would benefit from greatly in the future. Continuing with the architectural savings, because VRF on average is 30% lighter than alternative equipment, we can see that it can lead to structural savings where the structural steel and the beams can be cut from the beginning. This minimizes those upfront costs that you're spending on structural. And a good example that I've worked on this is, again, that speculative office building development here in Dallas, where we were able to go in and reduce the structural because the building footings that they were using had to hold up less mass, less weight. So we were able to remove that cost. And that led to significant upfront cost from the beginning. Additionally, if you're building a spec office or a multifamily building, VRF allows you to defer some costs. Some of these costs are because VRF is flexible and modular in nature and can install the system floor by floor or zone by zone, whatever works best for the application or the design of the building. I worked on a hotel here in Dallas where the hotel had to stay operational, and they were going in and adding VRF to the equipment and getting rid of the chilled water on the floor by floor. A strategy we deployed was to go in, add the outdoor units, and then go in and retrofit the floor by floor application of the hotel. And so after going through all 10 stores, you can continue to keep the hotel running, and as the new floors come online, those new floors can be rented out. But it's a great application to show how VRF is flexible in retrofit applications as well. Now let's look at this example here where we have a 3-story new construction office building in Milwaukee, Wisconsin. This is comparing a VAV system to a VRF system. Again, you'll see that equipment and ductwork is about $713,000 for the equipment on a VAV. Then you have screening, electrical, and structural steel for a total developer cost of $863,000 or $11.52 per square foot. You see it's in red as it compares to the VRF system because, well, with VRF, you gain some efficiencies, as we just discussed, with architectural and electrical, as well as structural savings. And you can see here that while the equipment is a little bit more at $110K, you're offsetting some of that equipment cost by reducing your screening, reducing your electrical, and also reducing your electrical steel, typically reducing your overall plenum height by 6 to 8 inches, which reduces your cost there by about $78,000. That's the biggest bang for your buck in reducing the height of that building. And the developer cost ends up being $862,000 or $11.05 per square foot. So now that we've discussed some first cost savings with VRF, what are some operational benefits that come post-development? You've designed it, you understand it, now you're operating the building. What are some benefits that you can get at that stage of the game? While maintenance associated with the fact of owning a building are inherent, it doesn't have to be a financial burden and a time waster, right? VRF offers simplified maintenance via reusable filters that can last up to 10 years. And the onboard diagnostics and monitoring also allow you to control the system and monitor system-wide what's going on with the system at any given time. This allows for easier maintenance time to maximize your operational costs. A good example of this is a student dorm that I worked for. in SFA here in Texas. It's a retrofit that required PTEX to be pulled out and VRF added in. The savings ended up saving the maintenance crew hundreds of hours a year because they were able to, one, monitor the building remotely just using VRF controls. And they were also able to diagnose things early on before even setting foot on the site. Right? They could view the errors that tell you exactly what the issue is, and they were able also to, via the onboard maintenance tool that we have, see temperatures and pressures without having to get out on the site and up on the roof first. It was like looking at the equipment from their computer. So with less time for maintenance calls, they were able to focus on the real issues that they had within their site. So it became a problem issue. VRF came in and were able to deliver a great solution for reducing long-term operational costs. So at this point, we understand that VRF is a precise energy use system. It uses the inverter technology to deliver exactly and precisely what you need. From that fact that we can see how the system is constantly running and always communicating, we can pull out information such as energy allocation to maximize the efficiency of the system. If you're building a development and you have multiple tenants, you would be able to go in and add some additional software and hardware to the VRF system to be able to generate projected energy usage as well as utility and apportionment for each tenant within that building to bill out for the rent. And so VRF would allow you then to create a bill to send to that tenant that you could easily leverage for better performance and to create a bill for that end user. Another point I wanted to mention in regard to efficiency is the City Multi-Efficiency Evaluator. I've used this tool many a times to position VRF against other technology. And what it does is a partnership between Willdan and Mitsubishi is it helps compare a project's energy usage, its first cost, and its life cycle cost, VRF against any other technology. The tool recently helped me work with a developer and an engineer to be able to position this to show that VRF was the best route to go for their new hotel development. Not all developers and building owners are going to immediately recognize the benefits of applying VRF, but the return on investment that we typically see with buildings built in a sustainable or with energy efficiency in mind typically provide better returns. We worked on a project here in San Antonio where the developer was building a new headquarters and decided to dig a little deeper and see if a high-performance building was the way to go. And they looked at standard construction code to see what the rate of return would be on that investment. And then they looked at designing with a high-performance building in mind. What they ended up finding was the rate of return was multiples higher than a standard build, and they were able to leverage VRF as part of that package to get the desired result on their investment return. So to give you another example, installing VRF systems significantly bumps the number of points that you can get from LEED certification. Here you can see that you would be able to get 21 points from energy and atmosphere and 7 points from indoor environment. So it's about 70% of the way to certified building LEED and 46% of the way to gold. And honestly, that's a huge leap from any other technology that you would see out there to get you halfway to your goal if LEED certification is your goal. So as Kevin mentioned earlier at the beginning of the presentation, the push towards decarbonization is a key effort among policymakers, utility companies, and interest groups. Evidence of this is New York City's Local Law 97, which sets CO2 intensity limits for large properties. That's a big shift in what we're seeing on the East Coast and West Coast here in the States, and hopefully it'll come to Dallas or Austin, I hope, at some point here in Texas. The other thing we see is the Carbon Neutral Cities Alliance, or the CNCA, which is a coalition of cities working to reduce greenhouse gases by 80 to 100% by 2050. And again, that's a very aggressive approach, but again, hopefully that will shift our mindset about how we design and the types of systems that we put into buildings. Key innovations like QAHV, which is shown here, are going to continue to develop. VRF is going to continue to grow, and innovations around VRF are going to continue to be rolled out. Mitsubishi has created a hot water heat pump water heater. I challenge you to say that 10 times fast, but it's a system that uses CO2 as the primary refrigerant with zero ozone depletion potential, because again, it's using CO2 as its primary method of refrigeration. And so when you're connecting it to generate a building's hot water, you can connect up to 16 modules of these to a modular tank or a holding tank to generate over 2 million BTUs of heating capacity. And so the water typically is going to come out 160 degrees or higher for that domestic water usage. So heat pumps are going to continue to be the method for heating and cooling compliance as we move forward here in the States. And there's a lot of exciting things happening within this industry that hopefully give you the tools and resources to really drive this application in more buildings. But I challenge you to continue to learn about VRF, continue to see where it can be applied in creative ways, and please reach out to your local Mitsubishi support to get started applying VRF and some of these other innovative technologies coming out from Mitsubishi. Kevin will now discuss some notable case studies that we'll cover. Kevin?
Excellent. Thank you so much, Jose. That was truly a really insightful and detailed look into the technology. I can't say hot water heat pump, hot water. I can't say it 10 times fast, so you beat me on that one. I personally really like the way you broke the costs into sections, the reduced initial or first costs, and then some of those post-development benefits. I know I'm sure we'll have a ton of questions for you at the end of the presentation. From what I can see, they're already rolling in pretty strongly here. A quick reminder to everyone that is on the phone to submit your questions using that Q&A function with the presentation within the presentation interface, and we'll get to your questions in just a couple of minutes. So now that we have an understanding of VRF technology and have peered deeper into how it can work in your favor and your customers' favor from a cost perspective, let's take a look at a few real-life examples where applying VRF systems resulted in superior energy efficiency and performance for a building. The first example, the Nomad, is a luxury 14-story hotel with 241 guest rooms in the heart of downtown Los Angeles. The hotel's ownership, the Seidel Group, has a passion for taking unique historic buildings and refreshing them with lavish accommodations and amenities. When they bought the historic Bank of Italy building, they knew installing a modern HVAC system was a must, but they also wanted something energy efficient and flexible to fit into their limited interior space. In addition, their challenge was heightened since they couldn't make changes to the building's exterior due to its historic status. To achieve their goals, the group selected a variable refrigerant flow system. Not only did the ownership group save money with the system's efficient operation, they also gained money by being able to add revenue-producing amenities such as a bar and pool, something that would have been impossible with a traditional HVAC system in their building. Additionally, the Nomad LA meets the Cal Green Building Code, which contains some of the strongest energy compliance standards in the U.S. and is typically difficult to achieve in historic buildings. Ryan Bean from the Seidel Group said, "Many of the existing city properties we develop are built lot line to lot line. There's no space to build a centralized plant that has cooling towers, boilers, and chillers. VRF was ideal for us because we can put units on the roof that have a small footprint." In the end, VRF was the optimal choice for the Seidel Group and the Nomad LA Hotel, and they really reaped a tremendous amount of benefits from the system. Walnut Hill Community Church holds a large congregation with a fairly expansive facility in Bethel, Connecticut. The HVAC system serving the 40,000 plus square foot facility was very outdated, with 4 32-ton ducted air handling units, a boiler, chiller, and fan coils. The facilities manager was told they needed a direct chiller replacement since the system was only working at 30% efficiency. The investment would have been astronomical for the church, and removing the large air handlers would have been a monumental task. Given those challenges, the church decided to look to other HVAC technologies that might lessen the construction burden and the impact on their facility. Using linear expansion valve kits, their mechanical contractor proposed a solution to connect the existing air handlers with VRF outdoor units and controls. This provided the church with the energy-efficient advantages and precision control of VRF technology, without the huge task of removing and replacing the air handlers. With the upgrade, the church was projected to save roughly $50,000 per year in energy costs, leading to a payback of approximately 5 years on their investment. Clay Norman, facilities manager of Walnut Hill Community Church, stated, "When we started looking at different brands and systems, I asked questions about energy, longevity, and the complexity of maintenance. There was no comparison between direct chiller replacement and the City Multi system. The 2018 cost was already 23% lower than 2017. That also represents a 23% reduction in energy usage, with an 8-degree higher temperature for 2018. The 10-story, 150,000 square foot mixed-use building at 800 North High Street was recently opened in the Short North Arts District of Columbus, Ohio. It houses 2 restaurants, an upscale hotel, and co-working space in this trendy neighborhood. Due to the conditioning needs of the diverse tenants, selecting an HVAC and ventilation system was a challenge for the owner. The wide-ranging tenants demanded energy efficiency and differing levels of ventilation based on how their particular space was being utilized. In addition, aesthetics were very important to the developer, the county, and the hotel brand occupying the building. The developer ultimately selected a 215-ton VRF system, along with a dedicated outdoor air system for ventilation. With VRF Technology's unique ability to add indoor capacity as spaces are leased, the developer was able to defer some of the tenant improvement fit-out costs to a later date. Lastly, the developer was able to secure a rebate through their local utility based on improved equipment efficiencies over ASHRAE's baseline figures. For every kilowatt hour improved, the developer could earn up to a 10-cent credit per kilowatt hour. Nelson Yoder is a principal at Crawford Hoying Development. He states, "We've noticed more options for savings by going with Mitsubishi Electric VRF. As we built shell office space, we were able to set up the infrastructure in a plug-and-play method where we wouldn't have to invest in 100% upfront. The selection of VRF was a win for this developer and will ultimately be a win for their tenants and their tenants' customers." There are a number of takeaways we'd like to leave you with after today's presentation concludes. These are, there are efficiency and cost savings associated with VRF technology. VRF systems reduce and can eliminate certain first costs. Installing VRF systems have long-term cost benefits, and the efficient operation of VRF systems can help improve a building's sustainability. The HVAC industry is ever evolving and will continue to do so well into the future. METUS will continue to invest in developing new technologies that further advance the energy efficiency, design freedom, and installation flexibility of HVAC systems to meet and exceed the needs of our market. That concludes the prepared portion of today's presentation. On behalf of Jose Hernandez and the entire Mitsubishi Electric Trane HVAC US organization, I want to thank you for the investment of time you've made in today's webinar. We hope you were able to gain new knowledge and ways to benefit from the cost savings of VRF systems. On the screen, you will find a number of resources available for your use after the presentation concludes today. These resources include our website, www.metahvac.com, a link to subscribe to our quarterly newsletters, and links to the case studies we discussed today. With that, I'll now turn the floor over to Scott to close out the presentation and open it up for questions. Scott?
Thank you, Kevin and Jose. It was a great presentation. Before we have our presenters address some questions that have been submitted throughout the program, I want to remind our viewers that we'd love their feedback in our webinar survey to help improve our programs, which is available on your screen now, or it can be filled out at the conclusion of the webinar. And speaking of questions, we have a lot of them. So let me pose the first one. This person is interested in the efficiency evaluator tool. Where can they learn more about it as a Mitsubishi distributor?
It's a fantastic tool. You know, Jose talked about the value of it and the work that he's done with certain projects. The Mitsubishi team, you know, whether it's through a distributor or through a Mitsubishi Electric Trane employee, has access to the tool. There's a significant amount of input training that goes into it. So the team's been trained. They can kind of guide and coach and work with an engineer on how to enter the inputs. Jose, when you sit down with a customer or one of our distributors sits down with a customer, what does that process look like? How intensive is it, and you know, can you get the results fairly quickly?
Yeah, Kevin, as a Mitsubishi employee, we're, as you mentioned, trained on it, but some of the basic information that you're looking to get the ball rolling is going to be whether it's a new construction or retrofit, where the building is located, and square footage and the application, right? Whether a hotel, school, or multifamily application is going to be key. And then the other thing that you're going to look at in needing is the comparison. What are you going to be comparing it again? VAV, chillers, PTAGs, all that information can be gathered up front. Typically, there's a pretty quick turnaround, and when you're familiar with the software, it can take less than an hour to kind of input all the information and get a pretty good output that most engineers and end users really like to use. I've used it even to the point where we submit it to utilities as the reason why they would extend an incentive. So it's high level enough, but utilities will accept it as well in certain areas as a reason for incentivizing that application.
Great, thank you. Another viewer asks, equipment noise is a big issue with their clients, and the question is, are VRFs quieter than conventional?
Significantly is the short answer to that question. The indoor units of a VRF system can operate down to 19 decibels, I think, at their quietest, which is equal to or slightly less than a human whisper. Traveling overseas quite a bit, I've stayed in many hotels. Hotels are a common issue with noise. We've all stayed in the hotel room with the very noisy PTAC system. You go to hotels overseas, a lot of times you have no idea if the system's even working. It's so quiet, but your room is comfortable and it's at the point where you set it at, if not better. So noise is certainly a benefit for these systems. Jose, anything from your perspective? I know you've worked with a few high-profile clients in your area, hotel clients specifically that I can think of. Noise is certainly something that's important to them, correct?
Yes, for sure. Noise considerations and noise pollution are key things to consider and are becoming more and more prevalent in hotel applications where you don't want a PTAC, but you want something that still delivers the comfort and controllability of the space. And then the other thing to point out is the outdoor units. Our indoor units are super quiet, but our outdoor units are also considerably quieter than most traditional commercial equipment, to the point where people put them outdoors and will put a rooftop bar or some green space up on the roof, and the units are sitting out there. And aside from initial startup, the units are very quiet to still have a conversation next to the unit and still be able to hear what everybody is saying.
Thank you. Another viewer asked, can you comment on the life cycle of the VRF equipment?
That is a common question. You know, we, like all mechanical systems, VRF systems, conventional HVAC systems are a replaceable product. It's got its life cycle. It runs through it. Typically, you see with VRF systems, if properly maintained, that's always the giant asterisk next to any mechanical system. If properly maintained, it's not uncommon to get 20 years out of the system. Obviously, there's variables that go into it, such as location. If you're, on a barge, for example, we've installed many systems on barges, tugboats. You're not going to get 20 years out of something that's sitting on the ocean. But if properly environment, it's not uncommon 20 years out of the systems. We came to the U.S. markets in 2002, 2003, so we've recently are approaching that point where systems are reaching the end of their life cycle, but it's definitely a longer life cycle than conventional systems. Jose, anything to add from your perspective?
Yeah, I would just say that, contact your local Mitsubishi office or distributor, and they'll be able to give you a sort of a maintenance plan to make sure that you tackle some of those things year after year. Typically, you're just cleaning the outdoor condenser and changing filters, but there are some other things like software upgrades and things like that that will help your system perform better. And making sure that you're doing some preventative maintenance is always key to make sure that you extend that longevity and you're not having any issues 3, 4, 5 years down the road. The other thing I'll point out is to make sure that if you are leveraging VRF and you're using Mitsubishi Electric, that you get with your contractor and make sure that they submit their extended warranty paperwork so that equipment will be covered under the extended warranty period, which for Mitsubishi is 10-year parts and 10-year compressor.
Good advice. Another viewer asks, when sizing VRFs for a speculative office building, how well can the system accommodate the introduction of unique and excessive loads such as a computer room or data closet? In addition, what do you do to segregate these loads so that the tenant can pay for their unique demand?
Yeah, so I'll kind of tackle the first part and then let Jose jump in with design considerations and potentially some information on some energy allocation software. Really, that's one of the hallmarks of VRF technology is flexibility. If you plan for your building, you kind of assume what you want your building, what tenants you want to occupy it. Let's say you're building an office building. You assume that there's going to be some kind of closet or room for servers or data equipment. You would factor that into your upfront calculations for the outdoor units. And really, in one of the examples that Jose walked through, you're sizing up the outdoor units for the total load of the building or the total potential load of the building, knowing that with a VRF system, you can modulate your connected capacity, so to speak, that, if you size it for 100%, it always doesn't run at 100%. It may run at 110 or 120 for a short period of time. But you want to take that into account when you're setting the outdoor units. The fit out of the indoor units is a lot easier than that. You're basically just modifying styles and sizes to fit the requirements of the space. Jose, did I butcher that, or did I state that pretty accurately from your perspective with tenant fit outs?
Yeah, I think you did a good job there talking through the different applications in a tenant finish. As he stated, there's a lot of flexibility with it. If you're going to be designing with VRF, I recommend, again, that you reach out to your local Mitsubishi support and get trained. We offer a class that kind of walks through how to make some of these selections. And then also please visit mylingdrive.com or train.mylingdrive.com And what we do there is have application notes that you can read and review about how to apply VRF in specific applications like a data room or server room where the load is going to be different than a data closet or a office space, right? So how to really apply those products. We have software training for that, and that helps you kind of understand how your building is going to be functioning from the get-go, and it helps Mitsubishi and Trane come in and support some of that design effort early on.
Sounds like great resources. Another viewer asks, what options are there to achieve outside air requirements with VRF systems? DOAS, natural ventilation, others?
Yeah, the ventilation is becoming an increasingly important topic as it relates to health and well-being of occupants. Obviously, the COVID pandemic that we're currently immersed in has brought that conversation to light even more than it already was. It really is dependent on the part of the country that you're in. You know, Jose, from your experience, how do you handle that with customers in the south portion of the country? I know that you might not be able to speak to some of the other portions, but how do you approach that conversation?
Yeah, in Texas, you definitely need additional ventilation, and the code, I think, is driving towards the fact that you need ventilation no matter what, right? So check your local code and make sure that you're adhering to that, but you will, in some instances, depending on where you're located, use a dedicated outside air system to bring in that ventilation. You will also, in some instances, hybridize a VRF system and use some modular applications that we have for ventilation, energy recovery ventilators, which we call LOSNAs, and some dedicated outside air units, pancake-style units that do some local modular heating and cooling of the outside air. But your strategy for how to handle that outside air is going to vary, again, depending on the region that you're in, the application that you're working with, hotel versus a school versus an office space. But those two design strategies go hand in hand, and so just make sure that you're adhering to your local codes for the outside air requirements, and know that you can rely on Mitsubishi to help you through that with dedicated outside air equipment or more modular LOSNA equipment.
Thank you. This viewer has actually two questions. The first question is, can you discuss VRF for retrofits? And his second question is, can you discuss fan energy savings with VRF?
So retrofits is a fairly common application. You know, I would say how we got our start, and I probably would say the majority of our business, I don't know this for certain, is probably retrofits. You know, over the last 3 or 4 years, we've gotten much more involved in new construction. But our market is pretty immature when it comes to HVAC. We don't have a lot of the constraints that you see in other parts of the world. Generally speaking, our energy costs are still pretty low. We have a lot of space. We don't really face the constraints that you see in Asian countries, some of the countries in the Middle East when it comes to those two items. But as our codes and our laws and our approach is changing, people are trying to retrofit existing buildings where a system has reached the end of its usable life with something that's more energy efficient. So I would say the process for retrofit and renovation with VRF is simpler than I would say the new construction. But we really do both of those on a regular basis. Jose, your thoughts on that? I know your market's probably newer when it comes to new construction, so you may deal with that more often. And then the second part, the fan energy savings, I'd love your thoughts on that as well.
Thanks, Kevin. Yeah, the retrofit and new construction mix is pretty even in my area. We get into both, and VRF offers a great solution because it's modular and scalable in either application. But in retrofit in particular, we have a 2-pipe heat recovery system, which minimizes your space requirements for running all the pipe work and ducting associated, right? You can do ductless systems in spaces that normally don't have high floor-to-ceiling space. And so it becomes a very lucrative way to redesign some of these and update some of these older buildings. But even with that, you can maximize some more of the space, as we talked, in hotel applications or multifamily applications that are getting renovated. But to speak on the fan energy, taking the office, for example, where you have maybe a rooftop and a VAV system delivering the comfort in the space, those fan-powered boxes are typically going to be powered by a larger fan box than we would have with a marginal VRF fan coil unit that pulls, in some instances, less than an amp, like our cassette units that we talked about. And so ductless, for sure, will drive that fan efficiency less because you're not having to overcome any static pressure. But if you are doing a ducted unit, even those units do pull quite a little bit of power, a little bit more than a ductless unit, but you can usually gang up 3 or 4 on a single 20 amp breaker and still be able to deliver the comfort that you're looking for. And again, take advantage of that energy reduction and electrical cost reduction to lower your upfront costs.
Thank you. Another viewer asked, what are the primary differences between the various VRF systems?
I think at their basic, a lot of the systems share some commonalities. The technology was born out of Japan and is really innovated from there on some pretty simple concepts. I would say the biggest difference that you're going to see is, and Jose briefly mentioned it, and I'll ask him to talk about it in more detail, is 2-pipe versus 3-pipe. And when we say that, we refer to refrigerant piping, a liquid line, a gas line that go from the outdoor unit to the indoor unit. Mitsubishi electric systems are unique in the fact from a heat recovery standpoint, which is a system type that allows you to heat and cool from the same system at the same time. It's a 2-pipe configuration and design. Other manufacturers on the market, for the most part, are 3 pipes. There's an oil recovery pipe that's in there as well, which adds material, it adds labor, it adds cost to the installation and maintenance process. Jose, would you say that's the biggest difference in your mind as you think about the various competitive brands on the market?
Yeah, I think that and the local support. I think I always go back to the people that are supporting the effort to get that done. Mitsubishi has been in the States for a long time and shows the track record to prove that. We also, make sure that we have the right mix of equipment and support into the space. But 2-pipe versus 3-pipe, I think, is a good differentiator, and there's some inherent benefits of a 2-pipe over a 3-pipe, especially when you look at retrofits and the space that 2 pipes would take versus 3 pipes. And, you can have either or discussion of which one's best for your application. But I think for the most part, you'll find that the support and that 2-pipe heat recovery application really give you a lot of benefits for the end user and the designer as well as the installer.
Great. We have time for one more question. And the viewer asks, why ever use a ducted VRF system?
Ductless seems easier, and it seems like it would be the better way to go. I think it's really application dependent. When we talk ducted, for the most part, we're talking short-run ductwork. We're not talking, large 18 to 24-inch spiral ductwork within a building. This is very simple, short-run ductwork. Jose, I think we've seen some of this in hotels. You see ducted systems used quite a bit in hotels. Where else do you typically see those pop up?
Yeah, I think you're right when you talk about application specific, right? Some people just aren't quite ready for the ductless to kind of take over everything. But I think aesthetically, sometimes you're talking about architects that don't want to see that in the space. And so we work with them to make sure that we give them the look and feel that they're looking for. Hotels being one of those, right, that depending on the type of hotel that you have and the brand, you're going to have a certain filtration requirement, or you're going to have a certain aesthetic requirement that's going to drive you to a ducted style unit. We also see situations in schools or in, maybe not hospitals, but maybe guest, recovery rooms and things like that, patient rooms where the filtration requirement is a lot higher, and our ducted units afford you the ability to overcome larger static pressure that is typically required when you have higher filtration requirements in that space.
Thank you. And unfortunately, that's all the time we have for questions today. Please join me in thanking Kevin Miskowitz and Jose Hernandez for their presentations, as well as our sponsor, Mitsubishi Electric. If you have any additional questions or comments, please don't hesitate to click the Email Us button on the console, or if we did not get to your question, we'll share those with our presenters so they can respond to you directly. Please visit enr.com/webinars for the archive of this presentation to share with your colleagues, as well as information about our upcoming events. Make sure to tune back in for our next webinar, Getting a Grip on a Changing World of Bid Requirements, airing this Thursday, January 14th at 2 p.m. Eastern Standard Time. We hope you found this webinar to have been a good investment of your time. Thank you and have a great day.